with respect to x. All right, so differentiate the following expression with respect to x. So let's go ahead, and I like to call the expression y. All right, so I'm going to let y be equal to that expression that they have. So let y be equal to 3x plus 4. I like to call it y. Let y equal 3x plus 4 over x minus 2. I like to call it y. All right, now that I call it y, now that I'm supposed to differentiate it, you're going to have to use quotient rule. So dy by dx is, quotient rule tells us that first thing is you start with the bottom. So you start with the bottom, so it's going to be x minus 2. You always want to start with the bottom, times the differential of the top. The differential of the top is 3 minus the top times the differential of the bottom, and the differential of the bottom is 1 over the bottom square. Over the bottom square. All right, so that's how you find dy by dx. You start with the bottom and you end with the bottom square. You start with the bottom and you end with the bottom square. And so this is how we get dy by dx. So what does this work out to be? Dy by dx works out to be x minus 2 times 3, that's going to give us 3x, minus 6, minus, of course, 1 times 3 is 3x, it works out to be minus 3x, and then 1 times 4 is 4, and this works out to be minus 4 over x minus 2 all square. So that's dy by dx over x minus 2 all square. Now, it can be simplified if you want. You can say, well, minus 6 minus 4 is minus 10, and 3x minus 3x that gone. And so dy by dx works out to be minus 10 over x minus 2 all square. So if you want to simplify it like this, you can, which would be great. So that's dy by dx. No issues at all. That's dy by dx. Now let's look at the next part of the question. The next part of the question says the point P lies on the curve y equals 3x squared plus 5x minus 12. It says find the equations of the tangent and the normal at P. All right, and so let's do that. So for part 2, which is part B, it is telling us that y is equal to 3x squared. Y is equal to 3x squared plus 5x y is equal to 3x squared plus 5x minus 12. All right, that's what it's telling us. That is y. Now that that is y, we need to find the equation of the tangent and the normal. To find the equation of the tangent and the normal, first we need is the gradient. So we need dy by dx first. Now dy by dx is going to be equal to, carry down the power, and we get 6x. We differentiate 5x, we get plus 5. And so this is dy by dx. Now remember, it's at P. This is dy by dx at P, and P is the point 2, 1. All right, now the gradient of the tangent At P, the gradient of the tangent. The gradient of the tangent is equal to dy by dx at this point. So all we need to do is plug 2 into this right here. When x is 2, that will give us the gradient of the tangent. So the gradient of the tangent is 6 times 2 plus 5. That will give us gradient of the tangent. 6 times 2 is 12, plus 5, that's 17. So that gives us the gradient of the tangent. So now we can find the equation of the tangent. All right, so the equation of the tangent, I'm going to call it EQ of tangent. All right, EQ of tangent, that means the equation of the tangent. All right, EQ of tangent, meaning equation of the tangent. So the equation of the tangent is given by y minus, it's y minus yp. So the equation of the tangent is y minus the y value at p, which is 1, and that's equal to the gradient of the tangent, which is 17, into x minus xp, which is x minus 2. So this is the equation of the tangent. That's how we find the equation of the tangent. Soft. Now next we want to find is the equation of the normal. To find the equation of the normal is fairly simple. First we need is the gradient of the normal. But the gradient of the normal is equal to minus 1 over the gradient of the tangent. That's how we find gradient of the normal. And so the gradient of the normal is negative 1 over 17. That's the equation of that's the gradient of the normal. So if that's the gradient of the normal, we can go ahead and write down the equation of the normal. All right, we can find the equation of the normal. So the equation of the normal is going to be y minus y1, so it's y minus 1, and that's equal to the gradient of the normal, which is minus 1 over 17 into x minus 2. Nice and easy. That's the equation of the normal. All right, and nice and easy. That takes care of this question. Soft. Okay, nice and easy. Now let's look at the next part of the question now, part C. Part C says the length of the side of a square is increasing at a rate of 4 meters per second. It says find the rate of increase of the area when the length of the side is 5 centimeters. Now, this is differentiation, but we're going to use chain rule to do this question. So we have to use chain rule to do this question. So first thing I always want to write down is the length of the side of a square. So I don't know how you want to define the length of a side as a square. I will define it as L. All right. So let the length of the side of the square be L. So let the length of the side of the square be L. So if we can call the length of the side of the square L, and it tells us that the length is increasing at a rate of 4 centimeters per second, increasing is positive. So they're telling us that dl by dt, that's a rate, dl by dt, and they're telling us that that is 4. That's what they're telling us, dl by dt is 4. It says find the rate of increase of the area. So rate of increase of area, first thing we need to know is that area is equal to pi r squared. Just to put that down, area is pi r squared. Why am I thinking about circle? My apologies. Area of a square is the length square, or length times length. So that's area, length times length. All right. And it says find the rate of increase of the area. So they want the rate of increase of the area. So they want dA by dt. This is what they want, dA by dt. And we don't know how we're going to find dA by dt. This is what they want, dA by dt. But this is what we know about area. Area is L squared. Now look at this, guys. dA by dt using chain rule is dA by dL multiplied by dL by dt. Oh my God. Look at that. And that will allow us to find the rate of increase of the area. See it there? We're nice. So I already know dA by dL by dt. dL by dt is 4. And so now we just need to work out what is dA by dL. Now A is equal to L squared. And so that means dA by dL. dA by dL must be equal to, when you differentiate L squared, you get 2L. Nice. So now we can find dA by dt. So dA by dt, dA by dt is equal to dA by dL, which is 4, multiplied by dA by dL. dL, let me write it better. dA by dt is equal to dA by dL, which is 2 times L, and L, that they tell us that L is what? L is 5. So it's 2 times 5 multiplied by dL by dt. dL by dt is just a constant 4. And so 2 times 5 is 10. 10 times 4 is 40. And so dA by dt is 40. But we're not finished yet, guys. Rate of increase, area is in centimeters square. So it's 40 centimeters square per second. Per second is s to the minus 1. And so that is the rate of increase. That takes care of question 5. Nice and easy, soft. So that takes care of the differentiation aspect of the question. And now we're going to go to integration. So now we're going to go to the integration, which is question number 6. Question number 6, it says, let's look at what this says. It is saying, evaluate the integral from 1 to 2 of, evaluate the integral of 1 to 2 of